In this video, we will talk about a very important and practical problem. This is the case where, let's say we have a theater company and they have conducted a survey and they have figured out that their demand is actually two segments. The first segment of demand consists of general public, whose demand curve looks like 500 minus 5p. And the second segment of demand is made up of students, and their demand curve looks like QS equals 200 minus 4p. And we have to work with this. And what's really cool about this question is it also provides us a simple rule of thumb which can help us figure out what price should the company charge to maximize revenues. So I think the setup is fairly straightforward. Let's say the firm charges the same price. They charge a price of $35. We will see what is the demand for students, demand for general public. And then we'll compare and contrast that with a more optimal pricing strategy in which the firms could potentially increase their revenue from where they are right now. So part A asks us to graph this function. And as we have discussed, the demand curve typically is given as demand being a function of price, which indeed is the case. Demand is dependent on price. Price is that force which clears out excess demand and supply. However, when we draw these curves, we draw demand as quantity on the x-axis and price on the y-axis. So we have to, from this, obtain the inverse demand curve, and that's what we'll be plotting. So we'll start by just writing down the demand for general public. It's given by 500 minus 5p, and we need to get p by itself, so we can write 5p equals 500 minus q general public, or p, and I can just specify general public. We'll start by the firm charging the same price, so it won't really matter. But this is given as 100 minus 1/5 Q general public. So this will be the demand function that we'll plot for general public. Similarly, the demand function for students is given as 200 minus 4p, and we can write 4p by itself. We get 200 minus QS, or price P equals 200 divided by 4 would be 50 minus 1/4 QS. So it is these two curves that we will plot on the curve, and once we plot these, we get this demand curve. And this demand curve shows that the demand for students lies under the demand for general public. So for general public, the y-intercept was 100, which is a y-intercept. And then when price is 0, if we look at this, demand will be 500. So this is how we get the second point. And then for students, the demand curve starts at price of 50, which is this. So this is our price of 50. And then we can plug in when price is 0, this will be 200, which we could have gotten from our equation also. When price is 0, Q is 200. And that's what the second the x-intercept for the demand function for students is. Now, part B of the question asks us to plot and find out what is the quantity demanded when price is 35. So we can work on both these graphs. It doesn't matter which equation we work with. So let's work with the original demand function to calculate the quantity demanded by general public and the quantity demanded by the students when price is 35. So to do this, we would write down Q general public equals 500 minus 5 times P, which is our 35, which once we simplify will equal 325 tickets. So this is the demand for general public, 325 tickets. And at the same price, let's calculate the demand for students. Demand for students is given by 200 minus 4p, or demand for students is given by 200 minus 4 times 35. And this amounts to 60 tickets. So what we have established is that in equilibrium, when the price equals $35, students will be buying 60 tickets and the general public will be buying 325. Now let's see what part B says. In part B, it asks us to find the elasticity of demand for each group at the current price and quantity, and that's the key. So we've already established that at the price of 35, which we have here, quantity demanded by students is 60 and the quantity demanded by the general public is 325. And we can use this to calculate elasticity of demand for both these groups. So just to reiterate, the demand curve for general public is given by 500 minus 5p. And we know also that the elasticity of demand is given by minus b divided times p over q, where we've seen that the elasticity demand curve of this function a minus bp. And this is what we had seen in chapter 2. So with this reasoning, our b is 5. You can find elasticity of demand is minus 5, and our price is 35, and our quantity is 325. So once we solve this, we get that the elasticity of demand for our general public is minus 0.54. So it is minus 0.54. So the demand for general public is highly inelastic. Now let's see what this is for students. We're told that the demand for students is 200 minus 4p. So elasticity of demand for students would be again minus b, which is minus 4 times p over q, and our price is still 35 and our quantity is 60. So if we do this math, we find that the elasticity of demand for students is minus 2.33. So what we have established is that the demand curve for students and general publics are different, and it's interesting that the elasticity of demand for general public is highly inelastic, minus 0.54, whereas elasticity of demand for students is highly elastic, is minus 2.33. So in the given scenario, both these groups are charged the same price. Our question becomes, is this the best we can do? Is there a different price we could charge? Specifically, could we charge a different price to each of these groups so that we can maximize the revenue we get from students and we can maximize the revenue we get from general public? And this is a really interesting concept. And we have a rule of thumb that if a company can control prices, they will maximize revenue if you charge, if your price is at the level where the elasticity of demand is -1. So if you recall, given that we have a straight line demand curve, this is the midpoint of the demand function. So revenues are maximized at the point where elasticity of demand is -1. So because we had different demand curves for each of these groups, let's find out the price at which this will happen. So we can say the elasticity of demand for general public, again we said was given by minus b p over q. We do not know what the p and q's are, but we want elasticity demand to be -1, so we can say -1 equals, and recall our b was minus 5 p over q. So if we simplify this, the negatives get cancelled. What it's essentially saying is that 5p equals q. Does that help us? Not quite, because we have two unknowns. However, we know that the demand curve is given as 500 minus 5p. So now we can apply that. We can say that our 5p should be equal to the demand curve, which is 500 minus 5p, which implies 10p equals 500, or the price should be 500 divided by 10. This price should be 50. So for general public, the ticket price should be $50. That seems to be pretty high, but this is the price at which this firm will maximize their revenue. So what is the price for students? We can apply the same logic. Students' revenue will be maximized when elasticity of demand equals -1, which is minus b over 4q of our student demand curve. So which implies -1 equals minus 4p over q. And this gives us that 4p equals q. Which q? Well, this is where we plug in the demand curve for students, which we had said was 200 minus 4p. So this implies to maximize our revenue, 4p should equal 200 minus 4p, or 8p should equal 200. This implies our p should be 200 over 8, which is 25. So our price should be $25. So we will maximize our student revenue if we charge $25 to students, and we'll maximize our general public's revenue if we charge $50 to general public. So at this price, what will the individual tickets be demanded? So we can again go back. We said that the price for general public should be $50. So the demand for general public is given by 500 minus 5p, and 500 minus 5 times 50 would be 500 minus 250, or 250 tickets. So general public should be sold 250 tickets, and that's what the demand will be when price is 50. For students, we know that the price that we charge them should be $25. So at $25, the demand for students is 200 minus 4 times 25, which is 200 minus 100, which equals 100. So what we have established is that students should be charged a price of $25, and at that price they will demand 100 tickets, and general public should be charged a price of $50, and at that price they will demand 250 tickets. So is this a better situation for the firm? Well, this is where we can compare the revenue from both the scenarios. In this scenario, our revenue will be the price students pay times the quantity that students buy plus price the general public pays times quantity of tickets the general public buys. And in this case, it will be 25 times 100 plus 250 times 50, and this is equal to $15,000. So if the theater company charges different prices to these individuals, then it will make a total revenue of $15,000. In the previous case, we had seen that they were charging the same price. So when they were charging $35, we had seen that the students were demanding only 60 tickets and the general public was demanding 325 tickets. At this price, their total revenue was basically the price times the total demand, which would be 60 plus 325, or 35 times 385, and this is equal to 13,475. So we see that by price discriminating and specifically charging at the level where the elasticity of demand for each of the segments equals -1, the firm can find the optimal price which will maximize their revenue. So this is a very realistic and detailed question, which really brings to the fore several things that we have done in the past: how to calculate elasticity, how to look at revenue, and the implications that these concepts have on pricing.